recently volunteered as an electrician for the Extreme Makeover Home Edition, and it was an incredible experience. I worked alongside 44 other electricians installing lamps in the house. One particular challenge was installing lamps in the master bathroom while 6 tile setters were simultaneously laying floor tiles. It really tested my patience, but we completed our tasks. The project took place during a rainy November weekend near Seattle. Despite the weather, we all kept our spirits up. I was impressed by the efficiency and teamwork on site. There were 50 painters who were painting the drywall very quickly so it was ready for use. Everyone worked hard to complete the home. It was an inspiring reminder of what can be achieved when people work together. I was so grateful for their hard work. I even offered the other electricians who helped out free attendance at my next electrical class. I highly recommend volunteering for Extreme Makeover Home Edition if you have the chance. It is an unforgettable experience that will challenge you, and you will make connections with people. The episode should air in about 2 months. I cannot wait to see it. The experience reinforced the importance of clear communication and coordination on a construction site. Before starting any electrical work, we had to coordinate with the other trades, such as the plumbers and carpenters, to ensure that our work did not interfere with theirs and vice versa. This required constant communication and a willingness to be flexible and adjust our plans as needed. Safety was also a top priority on the site. With so many people working in close proximity, it was essential to follow all safety protocols and wear the appropriate personal protective equipment. We had regular safety briefings to remind us of the potential hazards and how to avoid them. Another key aspect of the project was problem solving. As with any construction project, there were unforeseen challenges that arose along the way. For example, we encountered some wiring issues that required us to troubleshoot and find creative solutions. It was rewarding to be able to use my skills and experience to overcome these challenges and help ensure that the project stayed on schedule. Beyond the technical aspects of the work, the project also provided an opportunity to connect with other people and make a positive difference in someone's life. It was inspiring to see so many people from different backgrounds coming together to help a family in need. The experience reminded me of the importance of giving back to the community and using my skills to make a difference. From my perspective as an electrician, there are several key things to keep in mind when volunteering for a project like this. Firstly, it is essential to be prepared to work in challenging conditions. The work can be physically demanding, and you may be working in cramped spaces or in inclement weather. It is important to be in good physical shape and to be prepared to work long hours. Secondly, it is important to be flexible and adaptable. Construction projects are often unpredictable, and things can change quickly. You need to be able to adjust your plans and be willing to take on new tasks as needed. Thirdly, it is important to be a team player. Working effectively with others is essential on a construction site. You need to be able to communicate clearly, listen to others, and be willing to compromise. Fourthly, it is important to prioritize safety. Always follow safety protocols and wear the appropriate personal protective equipment. Be aware of your surroundings and take steps to avoid potential hazards. Finally, remember to have fun. Volunteering is a rewarding experience, and it is important to enjoy the process. Take the time to get to know the other volunteers and celebrate your accomplishments along the way. Electrical installations in residential settings must adhere to the National Electrical Code or NEC, which is a comprehensive set of standards for safe electrical practices. Some key NEC requirements relevant to residential lighting installations include, firstly, branch circuit sizing. The NEC specifies the minimum size of conductors for branch circuits based on the ampacity of the circuit breaker or fuse protecting the circuit. For example, a 15-amp circuit typically requires 14 American wire gauge or AWG copper conductors, while a 20-amp circuit requires 12 AWG copper conductors. Secondly, grounding. All electrical equipment and metal enclosures must be properly grounded to provide a path for fault current to return to the source, minimizing the risk of electric shock. Grounding is achieved by connecting the equipment to the grounding electrode system, which typically consists of a ground rod or a metal water pipe. Thirdly, ground fault circuit interrupters or GFCIs. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs monitor the current flowing in the circuit and trip if there is a ground fault, cutting off the power and preventing electric shock. Fourthly, conductor insulation. Conductors must be insulated to prevent electrical shorts and ground faults. The NEC specifies the types of insulation that are permitted for different applications. For example, non-metallic sheet cable or NM cable, which is commonly used in residential wiring, has a flame-retardant insulation. Fifthly, box fill. The electrical boxes must be sized appropriately to accommodate the number of conductors and devices contained within them. Overfilling a box can damage the conductors and create a fire hazard. The NEC specifies the maximum number of conductors and devices that can be installed in a box of a given size. Sixthly, cable routing. Cables must be properly supported and protected from physical damage. The NEC specifies the methods that are permitted for routing cables through walls, floors, and ceilings. Cables must be secured to studs or joists at regular intervals and protected from sharp edges or abrasive surfaces. Seventhly, lighting fixtures. Lighting fixtures must be installed in accordance with the manufacturer's instructions and the NEC requirements. Fixtures must be properly supported, and the wiring connections must be made correctly. Recessed lighting fixtures must be rated for the type of insulation that is installed around them. Eighthly, switches and receptacles. Switches and receptacles must be rated for the voltage and current that they will be carrying. They must be installed in boxes and properly grounded. Receptacles in bathrooms and kitchens must be GFCI protected. Ninthly, arc fault circuit interrupters or SIs. SIs are required in many areas of the home to protect against arc faults, which can cause fires. SIs monitor the current flowing in the circuit and trip if there is an arc fault, cutting off the power and preventing a fire. Tenthly, smoke detectors. Smoke detectors are required in all bedrooms and on every level of the home. They must be interconnected so that if one detector alarms, all of the detectors will alarm. Adhering to the NEC requirements is essential for ensuring the safety of electrical installations in residential settings. It is important to consult the NEC and follow the manufacturer's instructions when installing electrical equipment and wiring. Some additional information regarding lighting installations includes firstly, types of lamps. There are several types of lamps available for residential lighting, including incandescent, fluorescent, and light-emitting diode or LED lamps. Incandescent lamps are the oldest type of lamp and are relatively inefficient. Fluorescent lamps are more efficient than incandescent lamps and have a longer lifespan. LED lamps are the most efficient type of lamp and have the longest lifespan. Secondly, lighting controls. There are several types of lighting controls available, including switches, dimmers, and occupancy sensors. Switches are the most basic type of lighting control and are used to turn lights on and off. Dimmers allow you to adjust the brightness of the lights. Occupancy sensors turn lights on and off automatically based on whether or not someone is present in the room. Thirdly, lighting design. Lighting design is the process of planning and arranging lighting fixtures to create a desired effect. Good lighting design can improve the appearance of a room, enhance safety, and increase energy efficiency. Factors to consider when designing lighting include the size and shape of the room, the color of the walls and ceilings, the type of activities that will be taking place in the room, and the desired level of illumination. Fourthly, energy efficiency. Energy-efficient lighting can save you money on your electricity bill and reduce your environmental impact. When choosing lighting fixtures and lamps, look for the Energy Star label. Energy Star certified products meet strict energy efficiency guidelines set by the Environmental Protection Agency or EPA. Fifthly, safety precautions. Always take safety precautions when working with electricity. Turn off the power at the circuit breaker before working on any electrical wiring or fixtures. Wear rubber gloves and safety glasses to protect yourself from electric shock. If you are not comfortable working with electricity, hire a qualified electrician. Volunteering on the Extreme Makeover Home Edition was a great opportunity to put electrical skills to use for a good cause. The experience highlighted the importance of teamwork, communication, and safety on a construction site. It also reinforced the importance of following the NEC requirements for safe electrical installations. By taking the necessary precautions and following the proper procedures, you can help ensure that your home's electrical system is safe and reliable. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Firstly, Article 90.1 explains the purpose of the National Electrical Code or NEC. The NEC is a set of rules and guidelines designed to safeguard people and property from hazards arising from the use of electricity. It covers the installation of electrical wiring and equipment in buildings and other structures. The NEC is not a design manual, nor is it intended to be used as a substitute for proper engineering judgment. It is a minimum standard, and compliance with the NEC does not necessarily guarantee a safe electrical installation. Secondly, Article 110.3 discusses the examination, identification, installation, and use of equipment. Electrical equipment must be suitable for the intended use and must be installed and used in accordance with the manufacturer's instructions. Equipment must be identified for its intended use, and it must be installed in a neat and workmanlike manner. Equipment must be protected from physical damage and must be properly grounded. Thirdly, Article 210 covers branch circuits. Branch circuits are the circuits that supply power to outlets, lighting fixtures, and other electrical devices. The NEC specifies the minimum size of conductors for branch circuits, as well as the number of outlets and lighting fixtures that can be connected to a single circuit. The NEC also requires that branch circuits be protected by overcurrent devices, such as circuit breakers or fuses. Fourthly, Article 250 addresses grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, minimizing the risk of electric shock. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. The NEC specifies the methods for grounding and bonding electrical systems. Fifthly, Article 300 covers wiring methods. Wiring methods are the techniques and materials used to install electrical wiring. The NEC specifies the types of wiring methods that are permitted for different applications. Some common wiring methods include non-metallic sheath cable or NM cable, metal clad cable or MC cable, and conduit. Sixthly, Article 310 addresses conductors for general wiring. Conductors are the wires that carry electricity. The NEC specifies the types of conductors that are permitted for different applications. Conductors must be insulated to prevent electrical shorts and ground faults. The NEC also specifies the ampacity of conductors, which is the amount of current that a conductor can safely carry. Seventhly, Article 400 covers flexible cords and cables. Flexible cords and cables are used to connect portable appliances and equipment to electrical outlets. The NEC specifies the types of flexible cords and cables that are permitted for different applications. Flexible cords and cables must be protected from physical damage and must be properly terminated. Eighthly, Article 404 addresses switches. Switches are used to turn lights and other electrical devices on and off. The NEC specifies the types of switches that are permitted for different applications. Switches must be rated for the voltage and current that they will be carrying. Switches must be installed in boxes and properly grounded. Ninthly, Article 406 covers receptacles. Receptacles are used to connect electrical devices to the electrical system. The NEC specifies the types of receptacles that are permitted for different applications. Receptacles must be rated for the voltage and current that they will be carrying. Receptacles must be installed in boxes and properly grounded. Tenthly, Article 410 addresses lighting fixtures, lamp holders, and lamps. Lighting fixtures, lamp holders, and lamps are used to provide illumination. The NEC specifies the types of lighting fixtures, lamp holders, and lamps that are permitted for different applications. Lighting fixtures must be properly supported and the wiring connections must be made correctly. The NEC also requires that certain types of lighting fixtures be protected by ground fault circuit interrupters or GFCIs. Article 547 of the NEC addresses agricultural buildings. Article 547.1 states that the provisions apply to agricultural buildings or parts of buildings that house livestock and poultry. These buildings often have unique electrical demands and environmental conditions. Article 547.5 covers wiring methods. Wiring methods need to be suitable for the environment. Non-metallic wiring methods like non-metallic conduit, cables with corrosion-resistant jackets, and boxes made of non-conducting materials are typically required to resist moisture, corrosive agents, and physical damage from animals. Article 547.8 covers grounding and bonding. Proper grounding and bonding are crucial in agricultural buildings to minimize the risk of electric shock to animals and personnel. Equipment grounding conductors must be installed to ensure a low impedance path for fault currents. Article 547.9 covers equipotential planes. Equipotential planes are used in areas where livestock are confined to minimize voltage differences in the floor. These planes typically consist of a grid of reinforcing steel or copper conductors embedded in the concrete floor and bonded to the grounding system. Article 547.10 covers separate equipment grounding conductors. The NEC often requires separate equipment grounding conductors to be run with the circuit conductors to reduce electrical noise and improve the reliability of equipment. Article 547.11 covers receptacles in livestock and poultry confinement areas. Receptacles in these areas must be GFCI protected to reduce the risk of electric shock. Article 547.12 covers lighting fixtures in livestock and poultry confinement areas. Lighting fixtures must be protected from physical damage and must be suitable for the environment. Enclosed and gasketed fixtures are often required to prevent moisture and dust from entering the fixture. Article 547.13 covers motors. Motors used in agricultural buildings must be totally enclosed, fan-cooled, or tipped to protect them from dust and moisture. Article 547.14 covers surge protection. Surge protection is often required to protect sensitive electronic equipment from voltage surges caused by lightning or other events. Article 547.15 covers generators. Generators used in agricultural buildings must be installed in accordance with Article 700 or 701 of the NEC. Article 547.16 covers intrinsically safe equipment. Intrinsically safe equipment is often required in areas where flammable gases or vapors may be present. Article 547.17 covers wiring for emergency systems. Emergency systems must be installed in accordance with Article 700 of the NEC. Article 547.18 covers wiring for fire alarm systems. Fire alarm systems must be installed in accordance with Article 760 of the NEC. Article 547.19 covers communications systems. Communications systems must be installed in accordance with Article 800 of the NEC. Article 547.20 covers low-voltage systems. Low-voltage systems must be installed in accordance with Article 725 of the NEC. Article 547.21 covers solar photovoltaic or PV systems. Solar PV systems must be installed in accordance with Article 690 of the NEC. Article 547.22 covers wind electric systems. Wind electric systems must be installed in accordance with Article 694 of the NEC. Article 547.23 covers energy storage systems. Energy storage systems must be installed in accordance with Article 706 of the NEC. Article 547.24 covers interconnections with other systems. Interconnections with other systems must be installed in accordance with Article 705 of the NEC. The NEC provides comprehensive guidelines for safe electrical installations.